of you listen here. Today we will be discussing in detail about applications of dimensional analysis. This is more important for exam. Applications of dimensional analysis. Before that, we will do 2-3 examples of making dimensional formula. The next question is find the dimensional formula of coefficient of viscosity. This is a new term for you. This viscosity. Honey is a viscous fluid. Honey has high viscosity. If you take the liquids like petrol, diesel, they have very low viscosity. Okay, so viscosity, it is the fluid friction, actually fluid friction. Okay, between the different layers of fluid there is a friction existing. The equation of viscosity is, according to Newton, the viscous force between different layers of a liquid is proportional to, when we convert that proportionality to equation, there is a constant coming. That constant is coefficient of viscosity. It is represented by this letter eta. This letter is read as eta. So equation for viscosity is F is equal to eta into A is the area of the fluid layer, area, into dV by dx. dV by dx. Here dV means a small change in velocity. dV by dx is called velocity gradient. dV means velocity only. You can take the velocity dimension for dV because it is change in velocity. Dx is distance only, a small distance. Dx means very small distance. So here you can take the dimension of length. Here you can take the dimension of velocity. It is a small change in velocity. Here you can take the dimension of area. Here you can take the dimension of force. Then you find out the dimension of eta. That is the question. Got the answer? So first of all, we can rewrite the equation for eta because we need to find the dimension of eta, coefficient of viscosity. So I can write eta is equal to force into dx. This dx will go to numerator and adv will go to denominator, divided by area A into dV. Then we will apply the dimensional formula of eta. Coefficient of viscosity can be written as, force already we know, it is mLT raised to minus 2. mLT raised to minus 2 into dx means a distance only, so L again, divided by area, again L square, length into breadth, it is L square. dV is velocity is meter per second, LT raised to minus 1. Velocity dimension is LT raised to minus 1. Okay, so here in this case this 1 L will get cancelled here. Out of these 2 L's, again 1 L will get cancelled. Now only 1 L will become at the denominator. T raised to minus 1, T raised to minus 2 will cancel. Only T raised to minus 1 become numerator. M is remaining. Then here 1 L is here, that will go to numerator as L raised to minus 1. Okay, out of L square 1 L is cancelled, 1 L is remaining. So M, L raised to minus 1. Then here we have T raised to minus 1 remaining. Okay, 1 minus 1 is cancelled. So T raised to minus 1. It is the dimension of coefficient of viscosity. Find the dimension of torque. Second question is find the dimension of torque. Its symbol is tau. This letter is read as tau. If you want to rotate a body, okay, you need to apply a torque. If you apply a torque, then only you can rotate a body. Okay. See, on this pen, if I am applying two forces in the opposite direction, equal and opposite on towards right and left, it will cancel each other. Okay, the forces are cancelled each other. Now suppose here I am applying the same way in the force, one at this side towards right and at this side towards my left. Then these forces are acting in different line of action. Okay, one line of action is this way, another line of action is this way. If line of actions are different, and then these two forces will not cancel each other, that will have a turning effect. Because of that turning effect, it will start rotating like this. Got it? If you apply like this, line of action of force is this way, another force also this way, same line of action on the pen itself, so they will cancel each other. But if there is line of action here in this direction and another line of action this way, there is a perpendicular distance between the two line of action, then that two forces will constitute a couple, and that couple will have a turning tendency, means it will exert a torque on the body to rotate it. And this torque acting on the body is given by product of one of the forces. One force is acting this way, another force is acting this way. Torque is given by product of one of the forces and this perpendicular distance between the two lines of actions of forces. Here the length of the pen, in this example, length of the pen is the perpendicular distance between the two lines of action. Okay. So you got the equation. What is torque equal to? Tau equal to? Tau is equal to force multiplied by tau is equal to force into perpendicular distance between the line of action of two forces. Now you can find out the dimension. ml square t raised to minus 2. Correct?
Yes.
Because we have the dimension of force is ml t raised to minus 2. Mass into acceleration. Mass is m, acceleration is L t raised to minus 2 meter per second square. Into perpendicular distance means L only. So the dimension of torque will be ml square, L into L square, ml square t raised to minus 2. All of you got it?
Yes.
Now find out dimension of any physical quantity if you know the equations.